Good afternoon, everyone, and thank you for joining in on our webinar this afternoon on unpacking the new VCE methods and specialist study designs with Cambridge Senior Maths. My name is Kim Keane and I'm the National Webinar Presenter for Cambridge University Press. Before I make a start, in the spirit of reconciliation, Cambridge University Press and Assessment acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Islander peoples today. Please know this webinar is being recorded and will be distributed by email to all those registered attendees, along with a feedback form to include your feedback on your experience this evening. You can expect to receive this email within a week. You can ask questions in the chat box during the webinar. We'll be constantly monitoring this chat box. And so if you could possibly include your email address and name, that would be great. Just in case we can't get to all the questions at the end, it would be great that we have your details to be able to get back in touch with you. But know that you can wait until the end for our Q&A session, where you'll have the chance to be able to hear directly from authors and Cambridge team members as well. It's important to note that this evening's webinar has a large number of attendees. So if you do have a question that may not be specific to the authors, please pop it in the chat box and we'll have our Cambridge team communicate with you following the webinar. I'll be detailing publication dates as well, along with page-proof dates, and all of that will come along at the end of the webinar, along with pricing too. So stay tuned for that at the end. Before we begin, I'd like to introduce you to our esteemed authors who will be speaking this evening. Michael Evans has a PhD in mathematics from Monash University and a Diploma of Education from La Trobe University. He currently holds the honorary senior position of consultant at the Australian Mathematical Sciences Institute at the University of Melbourne. He was head of maths at Scotch College in Melbourne and has also taught in public schools, and in recent years has returned to classroom teaching. He's been very involved with curriculum development at both state and national levels. In 1999, Michael was awarded an honorary Doctor of Laws by Monash University for his contribution to mathematics education. David Treby obtained his Bachelor of Science with honours in mathematics at Monash University in 2005. He later obtained his doctorate in 2018. David has taught high school maths since 2006 and is currently based at Scotch College in Melbourne, where he is teacher in charge of extension maths. David's teaching interests lie in extending students with rich and interesting problems. David's also an active research mathematician, and most of his published work is in the area of mathematical physics. David Greenwood is the head of mathematics at an independent school in Melbourne and has 25 plus years experience teaching maths from years 7 through to 12. He has run numerous workshops within Australia and overseas regarding the implementation of the Australian curriculum and the use of technology for the teaching of maths. He's written more than 30 mathematics titles. Kay Lipson has a PhD in Statistics Education and Diploma of Education. Her experience includes over 30 years teaching mathematics and statistics at both secondary and tertiary level, as well as extensive periods as a VCE examiner. Kay is an experienced author of textbooks for the years 11 and 12 mathematics courses, specialising in the areas of probability and statistics. Let me also introduce you to our Victorian sales team. If they could pop up on the screen, that would be great. We've got Emma Kapler, she's a state manager for Victoria. Carolyn, who looks after the northern suburbs. Kim, who looks after east and southeastern suburbs. And Marcus, who looks after the western region. Thank you, everyone. Without further ado, please let me introduce our first speaker tonight, Michael Evans. Thank you, Michael.
Good afternoon. My name is Michael Evans, and I'm going to be talking about mathematical methods and specialist mathematics and how they're being treated in the new Cambridge University Press senior mathematics books. I'm going to talk about the differences and how we treat these differences. What's the difference in the study design for math methods 1 and 2? Well, matrices are other transformations, And of course, this implies they're out of Math Methods 3 and 4 too. Coordinate geometry is not listed, but there's some assumption that the students know their work from year 9 and 10. And you can see there, I have a quote from the study design, and it says that they have to have a sound knowledge of that year 9 and 10 mathematics. So to help with this, we provided the review chapters of linear equations and coordinate geometry. And I know that many people have their students do this during the holidays leading up to the year. So the students have got a good background when they come into the course. A big thing is the investigation, which will take 1 or 2 weeks, and you can build this into your teaching. That's the excerpt from the study design, and you can see that investigation is to be incorporated in the development of concepts, skills, and processes for the unit. So you can actually help with your teaching in this way too. So it doesn't have to be separate from your teaching, it can be part of your teaching. How do we help with this? Well, in each revision chapter, there's a section on investigations, and there'll also be online resources. We can see in the next slide that we have things such as this, different approaches and directions that the student can take, but these are suggestions for starts. And here we have the lost in the fog problem, which is a well-known problem, but it's about random walks with the person near a cliff and having a certain probability of going forward or back. Algorithms and pseudocode is another important part of these new courses. And that's the excerpt from the study design there. And it's listed in the key knowledge in outcomes, outcome 2 in units 1 to 4. So it's all the way through that the students are meant to have an understanding of this. In the textbook, it appears in suitable places, for example, bisection, algorithm, and simulation. And that's in particular for Math Methods 1 and 2, and this is repeated in 3, 4, and in specialist maths, I may add too, that there are places where we can use it. There is an appendix which covers an introduction to algorithms and pseudocode, and David will be speaking about this later on. So there's the contents for the appendix, and it provides a gentle introduction to these ideas. There's also online appendices with coding, because once you can actually write pseudocode, it's fairly easy to take it through to codes, and it's more satisfying, possibly if you could run a computer program and see the results at the end. And here we have them for Python, a computing program, which is a reasonably simple one for students to master, and the TI Inspire and the Casio ClassPad if they want to stay on their calculators. Python's now available on TI, I understand, as well. What's different? Well, we've got two, just generally in specialist math and math methods, we have 2 additional authors. We've got Dan Matthews from the Department of Mathematics at Monash University. And we've got Dr. Gareth Ainsworth, who's head of mathematics at Scotch College. So they've both joined the author teams. All the exercise sets have been refreshed, multiple choice questions all revised. So the questions in multiple choice questions are probably more CAS active type questions, where we know that the student has a CAS question, and that a lot of changes in both books due to that. Many, many more questions, not only in new topics, but in the old topics as well. And of course, the new topics are introduced in the books. Investigations are included in both Specialist Maths 1, 2 and Math Methods 1, 2. And in Math Methods 1, 2, we have a question guide to when it might be useful to use CAS, and this is done by a strip down the side of the page. Specialist Maths, there's a lot of change in Specialist Mathematics. It's fully prescribed for units 1 to 4, and that's probably the biggest change in many ways. Specialist Mathematics units 3 and 4 in particular assumes familiarity with the key knowledge and key skills from both methods and specialists. And so that's very important to understand, that there's an assumption that the students have knowledge of the material covered in specialist mathematics 1 and 2, as well as mathematical methods 1 and 2. As usual, it's assumed the student has either completed Math Methods 3-4 or is completing it simultaneously with this. Topics in Specialist Maths 1-2. I just mentioned the ones which are, they're not new totally, because some of these things have been there before. We've certainly had the first 3 in the study design before, it's just that they haven't been taught widely. But graph theory, logic, including Boolean algebras, proof and algorithms are topics which, as I say, they're certainly not the only ones, but the ones which may be new for you to teach. Proofs will involve concepts from topics. So this is now talking about 3-4. And you can see that it's referring to topics that come from Specialist 1-2. And so there's a wide range of topics there which can be brought to the fore to introduce proofs. Again, algorithms are in the 3-4 in the mentioned in the study design, so it's assumed all the way through that the students are familiar with these ideas. Another new thing is a vector equation or a straight line given the position of 2 points or equivalent information in both 2 and 3 dimensions, and the vector cross product, normal to a plane, and vector parametric and Cartesian equations of a plane. This is all new, and there's a whole chapter in Specialist Maths 3-4 on this topic. So you get questions such as, what's the distance between 2 skew lines, or what's the distance between 2 parallel planes, all those sorts of questions. In calculus, we've got surface area of solids and surfaces of revolution and integration by parts. What's next? Well, there's 3 individual talks coming up, and David Greenwood's going to be talking about algorithms and pseudocode. Okay, we're talking about probability and statistics in both subjects, and David Treby will talk about graph theory in Specialist 1-2.
Now, Michael has already mentioned some of the changes in the study design regarding the introduction to algorithms. I will spend just a few minutes providing some examples of where this occurs in the study design and where algorithms are addressed in the VCE Cambridge resources. First of all, let's just talk a little bit about what an algorithm might be. So when thinking about an algorithm, we might be thinking of the following: sequence of instructions, repetitive processes, notation, computational thinking, and technology. Now, we are already familiar with many algorithms, including completing the square, the algorithm for constructing a perpendicular bisector, for example, for polynomial division, and many of these have a limited number of steps. But if there are many more steps, then of course it might be too cumbersome to handle these by hand. And so a more sensible approach might be to construct an algorithm using technology and some kind of code. In Math Methods and Specialist Maths, the main areas where we apply algorithms are in Newton's method, which is an algorithm for finding the roots of a function, the bisection method, which does the same thing, in probability and simulation, and in using pseudocode. Now, many of you would therefore be pleased to know that no background in programming is needed to approach any of the new material in the study design or in the Cambridge resources. Those numbers next to these titles are the number of times that these words are referenced in the new study design. So first of all, let's have a look at Newton's method. One of the key skills in Newton's method in the Year 11 course in Unit 2 is to use the algorithm for Newton's method to find a numerical approximation to a root of a cubic polynomial function. In Year 12, a similar type of content descriptor. Just quickly on how Newton's method works, you can see we start at x0, gives us a point P0, and we use the tangent at that point to find x1 and so on until a degree of accuracy has been obtained. In the Cambridge series, we have an application of this where pseudocode is used to produce the outcome. So on the left, we have the pseudocode using a while loop to go through the processes of Newton's method. And on the right-hand side, we have the x values and the f of x values resulting from each pass in the program. Looking at the bisection method, right through the methods courses 11 and 12, we have an example here from the investigation, the exploration by successive iterations of the bisection method. A possible extension is to analyse the pseudocode for the bisection method algorithm. And an example here of how the bisection method might be applied. So on the left, some pseudocode to continually update the m value, which is the average of the a and b. So we close in on the root of the function or the x-intercept on the graph. Simulation. Key knowledge here to the purpose and effect of sequencing, decision-making and repetition, and their role in the design of algorithms and simulations. And the skill listed here, use computational thinking, algorithms, models and simulations to solve related to a given context. And in Year 12, a similar type of skill is listed in the study design for math methods in Year 12. In the Cambridge text, we have an example here where we are writing a simulation to estimate the long-term average for the number of rolls required of a die so that we first get a 6. So in summary, where are the sections in the Year 11 and 12 Cambridge books for methods and specialist maths? So in Year 11 methods, you can see here there are 4 key sections. In Year 11 specialist maths in Chapter 8. And in Year 12, methods and specialist maths. Also, there's a number of appendices, and the chapter reviews, of course, include questions relating to algorithms and pseudocode and simulation. And there are also sections in the revision chapters right throughout the series. As well as that, there are other appendices looking at Python, coding for the TI Inspire, and also the ClassPad. So I hope that gives you some idea of how these things, the algorithms, are addressed in the new study design and in the Cambridge series. So all the best, everyone. Thank you.
Good afternoon. My name is Kay Lipson. I spent several years at the beginning of my career teaching senior mathematics in schools, but the bulk of my career has been spent in universities teaching and researching in probability and statistics. I've been an author of the Cambridge books for many, many years. I'd like to talk today about the study area of probability and statistics, both changes that have been made to the curriculum and changes that we have made in the books. The biggest change that you're going to find in mathematics methods 1 and 2 is that the study area has been reallocated between units 1 and 2, with random experiments, simulations, and counting principles placed in unit 1, and probability of elementary and combined events, representations, and rules for probability placed in unit 2. After much contemplation and discussion, our response to this has been to keep the material together in the book, allowing teachers the flexibility of deciding their approach to the study area through their choice of which sections to teach at which stage of the year. As Michael has already mentioned, we have included a new section, Pseudocode for Probability and Simulation. The book also continues to include the chapter on sampling with and without replacement, which introduces the important concepts of random variables and the binomial distribution in preparation for Mathematics 3 and 4. In Specialist Mathematics 1 and 2, we see an increased emphasis on linear functions and sums of independent random variables. We've addressed this with a new chapter section, explicitly demonstrating the difference between x1 plus x2 and 2x, and extending these ideas a little further to the general case. And of course, including plenty of examples for practice. Here's an example from the new text, which specifically addresses the distinction. This emphasis on linear functions and sums of independent random variables continues in Specialist Mathematics 3 and 4. Here's the excerpt from the study design. Here we've taken a complete restructuring of the chapter's approach. In chapter 15, we now have devoted completely to linear combinations of random variables and leading to the distribution of the sample mean. Chapter 16 now covers all of the inference for the sample mean, by which I mean both confidence intervals and hypothesis testing. We've also taken a more conditional probability approach to errors in hypothesis testing, as has been the approach in recent examinations, rather than in terms of type 1 and type 2 errors, which was the approach in the previous versions of the text. Thank you. I hope you find our revisions and additions are helpful to you and your students in your teaching going forward.
Good afternoon, everyone. My name is David Treby, and I'm a maths teacher at Scotch College here in Melbourne. And I'm also a contributing author to the Specialist Mathematics Units 1 and 2 book, and also to the 3 and 4 book as well. Right, and so we decided to cover graph theory in this talk, and we've got a few reasons for doing this. First, as teachers, we know that new topics are often the cause of considerable anxiety to teachers. And we know that there'll be many teachers who have never studied graph theory, and many more who, of course, have never taught it. And so we've written the chapter very, very mindful of this fact. And so, the chapter itself is written to be friendly to both the teachers and their students. Another reason why we decided to talk briefly about graph theory this afternoon is that we wanted to point out how the treatment of graph theory is different in specialist mathematics compared to further mathematics. All right, so we see in further mathematics, the topic actually has a slightly different name. It's called networks and decision mathematics. And here we see that there's a very, very strong focus on applications. And, we see topics such as scheduling problems, critical path analysis. We see matching problems, shortest path problems, flow problems, minimal connector problems, and traveling problems. And what we'll actually see is that traveling problems is actually in common between the two subjects. In specialist mathematics, the topic actually has a slightly different name. It's called graph theory. And as the name would suggest, there's a much stronger focus on theory. So we see here, for example, that it's covering things like existence and construction problems, counting problems, types of graphs, so classification of graphs, trees, planarity of graphs, Euler's theorem, and traveling problems, which, as I mentioned, is actually in common between the two courses. Okay, and so the danger is, of course, that there's a lot of theory, that it can be scary and it can be off-putting to students and teachers. Okay, so one way of overcoming the fact that it is a little scary was to actually make sure that we provide complete solutions to each and every one of the exercises in the book. Now, that is actually not different for this chapter compared to every other chapter. We've actually done it for the entire book. So, but we do, of course, hope and expect that the solutions for the new topics will be more helpful, perhaps, especially for those for whom the theory is new. Okay, another way that we thought to overcome whatever anxiety the teachers have around the teaching of this topic, we thought that we would make a really special effort to exemplify and to soften the theory with fun and interesting problems. And so, one example of that is that, we're expected to cover planarity of graphs and construction problems. So an example that we've considered in the book, which we think is really fun and which will capture the interest of teachers and their students, is imagine 3 houses, and you want to connect each of these 3 houses to gas and electricity and water so that the connecting lines don't pass over one another. And so the picture looks a little something like this. So I've got house 1, 2, 3, and I've got to draw lines from each of those houses to each of the utilities that are shown in the red dots. Now, I'm not going to show you the solution here, or in fact, I'm not going to discuss even if there is a solution. You might like to have a think of that between now and when you teach it. But what we do want to say, of course, is that the book actually gives students the resources and theorems that actually enable students to answer these questions, really, really effectively. Okay, so the next, as we see, the study design also expects to cover so-called counting problems. And so, what's meant by that? I mean, here is another example, sort of taken from the book, or something very much like what we see in the book, of 9 people at a party. All right, and imagine that there are 9 people at a party, and every person at that party shakes hands with every other person at the party. And a very, very well-known problem is how many handshakes therefore take place. Okay, and of course, the best way to visualize that problem is to actually draw a graph with 9 vertices, with every vertex connected to every other vertex. And so we get a really beautiful picture like what we see there. And then, of course, the question then simply becomes, how many edges does this graph have? Where, of course, each edge represents a handshake between 2 people at the party. Okay, right, excuse my dog in the background there. The study design also mentions so-called existence problems. Now, again, I mean, what is mentioned by that? What is meant by that? So imagine at that same party of 9 people. All right, and what we want to arrange for each of the 9 people to shake hands, not with every person, but with exactly 7 other people. Is that possible? So, returning back to the picture, is it possible to draw the same 9 vertices so that each vertex is connected to only 7 people? And again, the solution won't or may not be obvious to you immediately, but again, we skill up the students and their teachers with the tools necessary to really efficiently answer such really nice questions. Okay, we also mentioned too, of course, that the traveling problems, that these are in common between further mathematics and specialist mathematics. And so, looking at exactly the same graph, the graph with the 9 vertices, can we draw that picture without taking our pen off the page, right? So there's the picture just there. And, it's certainly, it's not going to be obvious from the picture alone. I mean, can you do it? Maybe. I mean, you might like to, draw 9 dots on a page and see whether you can do it. But again, we're going to give teachers, their students, the tools to know, even without drawing the picture, can it be done? Okay. Another problem is that is really important and which we cover at great length is the idea of planarity of graphs. And I already mentioned that with that utility problem and the 3 houses. But, returning back to the same picture across here, can we redraw that graph so that there's actually no intersecting lines? And certainly doesn't seem like we ought to be able to. I mean, there's a lot of edges there and maybe not enough vertices in order to do so. But we quantify these ideas in the book. We actually come up with, again, ways of knowing quite effectively and efficiently whether or not it can actually be done. And I mean, just to indicate here, I mean, with 4 people at a party, imagine 4 people at a party there, each person shakes hands with every other person. Here the graph actually can be redrawn so that the edges don't cross. I mean, you see the first picture on the left, the edges of course cross, but imagine that one of the edges is made from like a flexible piece of elastic, and then we drag, I've sort of indicated that in red on the right hand side, and imagine dragging that flexible edge so that it no longer intersects any of the edges. Okay. And of course, I mean, there's going to be other ideas in the course and in the book, which are so beautiful and so interesting, that it's going to be really easy to motivate students to see, to see the beauty and to see the applicability of the topics that you discuss. I mean, a personal favorite of mine, of course, is Euler's polyhedral formula, or just Euler's formula, which gives you like a beautiful relationship between the number of vertices and edges and faces in a graph. And we look at a proof of that result. It is actually surprisingly easy to prove, and you'll see a nice proof of that in the book. And you'll see a rather large range of really nice applications of that result as well. Okay, thank you so much for joining us and joining me for this very brief discussion. I'm sure the other authors will have more to say on other aspects of our offering. If you would like to contact me about anything that I've mentioned here, or to ask any questions about what we have to offer in the books, please reach out. That's my email address just there. And thank you so much for your time and for listening to me today. Take care.
Thank you so much to the authors this evening for their insights. Let's get ready for the Q&A. So introducing everyone back into the screen if we can, that would be great. Good, and let's get started with some questions. Have we got any new questions that anyone has sitting ready to go? If so, please pop it in the chat box for us and we can get started sending these out to appropriate authors or Cambridge team members.
Kim, I might just start us off and perhaps ask Michael to summarise some of the main changes for methods. He has talked about it briefly already in the presentation that we saw, but I thought it would be a good opportunity to just recap some of the main differences this time for methods first up.
Great idea. Thanks, David, if you could.
We'll go first to Michael.
Oh, sorry, Michael.
Yes, look, the changes in math methods are minimal, really. It's certainly not going to be a big change in your teaching. There's a few things, such as the median's been dropped out of probability and stats, which is a minor change, and really related questions are still there. We've got Newton's method coming into year 12, so it means it's now more clearly examinable. That I mentioned during the video that matrices have been dropped out, so that it changes the way you do transformations, but it doesn't change the content of the course that much. Probably the part that's a little bit different is hidden in the, it's not really hidden, in the key knowledge and key skills, where you've got pseudocode and algorithms, where it's clearly required to address this. I'd just like to reassure people that it's, when you start reading through it, it's very easy to handle, and I'm confident that students would be able to handle it. We've taken a lot of time over it. We've color-coded our pseudocode so you can see where loops are, etc. So it's easy to pick up. These are really important ideas in modern mathematics, and so to avoid it would be, to keep on avoiding it would not be a wise thing to do. David, David Greenwood, have you got anything else to say about math methods? There are other things.
Just to agree with you, Michael, on how easy it is to get into the coding. You don't need to know a language to get started here. And you'll notice the way it's been presented in the text that if you are a maths teacher or a student of mathematics, you'll be able to read through and use a logical approach to understand how pseudocode might work in relation to mathematical ideas like the bisection method or Newton's method. So once you have your mind around what the Newton's method is and how it works, you'll see that the pseudocode is really just describing those steps that you go through when you run through the algorithm.
And there is some support that we've tried to, the authors have tried very hard to provide an appropriate level of support, both introductory, going back to basics about what is an algorithm, what is pseudocode, all of that kind of stuff, as well as specific support for different ways of turning pseudocode into code that can be run on using Python or the various CAS calculators. Michael, do you want to talk a little bit about that appendix support?
Yes, look, it seems when you're doing these sort of algorithm design, it's nice to be able to run them on a device. And it's not explicitly part of the course, but it can aid people's teaching. So we're providing appendices on coding in Python, which is probably the most friendly programming language around at the moment. And it also is on the TI platform as well as free on downloadable. So there's no cost involved in downloading Python and running with it. And we're going to support the two calculator programming languages too, but I put them a slight step behind as easy to handle and when you're on a small device. So I think we've reached the stage where people can actually run it on their computers with Python or some other programming language, but it's not going to be a compulsory part of the course. It won't be examinable, that part of it. It will only be to strengthen understanding of the pseudocode and what it does.
Okay, well, let's run to some of the questions that we've got coming through the public chat. So first one from Troy: how are past exam questions incorporated into the text?
I'd firstly throw to Michael on that one, who can talk about it generally across the methods and specialist books, and then I can add a few things after that. Michael.
Yes, okay, this time we've gone through carefully all the questions and there's been adjustments to match exam style questions. So in both subjects, there's swathes of changes, probably in methods and the multiple choice questions. There'd be around about 50–60%. So some of those old questions in there, like the derivative of this is A, B, C, D, E, gone, because they weren't examining all sorts of questions. And what we replace them with is exam type questions with the understanding that a student would have a CAS calculator. And the same in both subjects. It's really quite extensive. I know I can say I'm painfully doing solutions for specialist maths at the moment, and there's just a vast number of new questions which are based on exam questions. So yes, we've taken a lot more trouble with actually replacing them in that way. Look, you'll still do exam style questions another way, and Scott might talk about that too soon too. So others might have something more to say about this too. Kay, you might have something to say about that one. You're on mute.
You're on mute, Kay.
Sound better on mute. There's been, I need to agree, Michael, sorry, there's been a big reflection, particularly, I think I mentioned it earlier, that we've changed the approach to the inference probabilities area to really reflect the way the recent examinations have approached it, more conditional probability approach, a lot more emphasis on linear combinations of random variables, and to go with that, a tremendous change in the exercises. So I'm very confident that we are now reflecting much more closely what's being examined.
Great.
And just to add to that, apart from the content in the textbooks themselves, what we are doing this year is adding a feature to the online teaching suite called the Exam Generator, is the name that we give to this. It is similar to the Test Maker or Test Generator that some of you may be familiar with, using test style questions, but the Exam Generator consists of a massive bank of past exam questions, literally actual questions from the last 8 or 10 years of VCEE exams, all the way back to the start of the previous study design and prior to that as well as the bank built up even more than that with authored questions in the same style. So that's something that we'll be talking about in more detail in term 3. But some of the main features of that, just the ability for teachers to search the bank using keywords, to filter via particular areas of study and drill down into topics and subtopics, to set multiple choice questions and have those marked automatically if the exam is set online, or to be able to print an exam using any question types and have it look like the exams that students will encounter at the end of the year. These customized exams can be very targeted, or they can be quite general to model the end of year exams. There's going to be a lot of flexibility. As I said, there'll be more information about that coming in term 3. Any further questions, Kim?
Yes, so you've actually answered Harry's question, which was next, and really about the extra content for teachers. So you've answered that one for him. So we'll move on to Jessica. Within the textbook, have you identified the areas where the proofs for units 3 and 4 will come from, given it could be based on anything from unit 1 and 2?
I'll throw that one over to Michael first of all.
Okay, and I'll ask David to join in too. But we've literally got hundreds of proof questions in the 2 books, hundreds and hundreds, must be close to thousands, and we're providing extra skill sheets and assignments. So all we can do is, in a sense, give you where the choice can come from. I think we can say examiners will be very cautious with how they bring this in. So I wouldn't get too scared about it in that sense, because the study design looks very broad, but I don't think examiners would be particularly ambitious in the first year. But you can actually go through that range. And as I say, our materials offer just vast numbers of questions which are suitable. And they start from very easy, which I'd expect would go to peer and exams to start with, to very difficult type questions in specialists as well. So we have got a huge range of all the different sorts of proofs that are in the study design and from the different areas. The study design explicitly says that Math Specialist 3-4 assumes the knowledge of Specialist 1-2. So you actually have to take that literally. So for the first time ever, you actually have to know your Specialist 1-2 work as well. It doesn't only go for proofs. You'll find it in things like circular functions / trigonometric functions are not in the study design for Specialist Maths 3 and 4. But you cannot do Specialist Maths 3 and 4 without having an extensive knowledge of trigonometry. In complex numbers, they don't mention Cartesian form in 3-4, but of course, to even start in complex numbers in year 12, you need to know Cartesian form. So you have to assume that Specialist Maths 1-2 is required for Specialist Maths 3-4. In this first year, of course, we haven't had people doing the full course, and so that will have to be taken into account too by examiners. They've had some idea of what's coming, but I don't think you know everything about it. None of us do, actually. I'm not on those panels, so I'm not exactly sure how that's going to form. But on the other hand, it's you do have to assume that in the long run, that Specialist Maths 1-2 is required for Specialist Maths 3-4. David, have you got more to say about proof?
Yeah, I mean, I will just add that, so, you know, as Michael said, that we really sort of do, regardless as a 2-year course, and doing the proof questions for the year 11 book would be well and truly worth doing, kind of, you know, as a lead up to doing the same sort of questions again in year 12. We've tried to include like a good range of questions on topics we think are most likely to be reflected in the exam, because we can't, you know, predict with absolute certainty. We're going to augment other questions in the book with a range of skill sheets, which kind of, you know, which sort of aims to cover all bases basically, but with like a main emphasis on what we consider most likely to appear.
Sure. So let's move on. Despina has asked, how has the online and interactive textbook changed?
So I'll field that one first of all, and I think there was also a question more generally about what has been added for the teacher resource as well. So I talked about the exam generator, which is something that it will not be a subscription model that it costs some extra amount of money per year in addition to the price of the textbook itself. But that will be included just as part of the normal features that you'll see. So in addition to that, we'll be providing 4 chapter tests per chapter. More skill sheets will be included in the teacher resource as well. There'll be sample investigations. I think we're going to get to the investigations in units 1 and 2 for both methods and specialist in a second. We can talk a bit more in detail about that. There'll be sample material on that as well, in addition to what's in the textbook. We will be, in terms of the student side, there'll be worked example videos for video demonstrations of every worked example. In the previous edition, as people would know, if they're current users, that applied to a selection of the most illustrative worked examples for each chapter, but this time there'll be videos for all the worked examples for the whole series. There's a bunch more things, but those are the things I can remember off the top of my head.
Great. Next one is from Ruby. Is there anything included in Maths 1 and 2, but not in Methods 3 and 4?
Strictly, everything in Math Methods 1 and 2 is examinable in 3, 4 as before. That's been the case before. There's some understanding of the limitations of that. But when you look at the syllabus now, it more melts into the 3, 4 syllabus smoothly. So I would say no, probably the bisection method isn't mentioned explicitly in 3, 4, but on the other hand, you could see a question being developed in extended answer type, extended response type questions, which reflect that as well. So I would say you really do need to know your Math Methods 1 and 2. There's quite a big overlap still between 1, 2 and 3, 4, and some of it's repeat, as we do in our books. And now at the beginning, as I mentioned before, we repeat some of the 9 and 10 material, which has been taken out of the study design, but you can't do Math Methods without it.
Of course.
That's a fair way of saying it. David Greenwood, have you got something more to say about that?
Interesting. Look, I was just thinking when you said, Michael, about the bisection method, like I could imagine that a question maybe with some pseudocode could be presented with the application being in the bisection method. So I noticed there might have been a question there about an example for pseudocode, and I'm just thinking of one now where some pseudocode might be presented rather than being asked to be produced. And then a student might then have to interpret the pseudocode, run through it, and perhaps produce a table of values, which might be what is printed or what is the output of that. And so perhaps in Year 12, there could be some examples where some Year 11 examples are being used as a context.
Yeah, I think I agree with that. But also, multiple choice is a very easy place to test pseudocode, because you can say which of the following is the output of this stretch of code. And so you'd expect those fairly quickly, I think, because they're easy to make up, actually, and easy to mark. Always remember, examiners have the problem of setting questions which are easy to mark. So we wouldn't expect questions where people have to write lots of pseudocode and be interpreting pseudocode and maybe changing it slightly, just because examiners have to have a clear pathway of marking.
Okay, moving on to the next question from Megan. We haven't used Cambridge before and are looking at new textbooks. Do you have an online video component inside Cambridge? Scott, do you want to quickly respond to that one? It's a pretty easy question, isn't it?
Yeah, the answer is yes. There will be a few other types of videos that we'll be presenting in addition to the worked example type videos. Yeah.
Great. Next one from Mark. A lot of new material has been added to specialists. Michael, this one's specifically for you. Do you think there is now enough time to teach it, and how it should be sequenced?
I think we can say it's a demanding course. One of the most important things is that the student has to have material from specialists Maths 1 and 2 under their belt. If they do that, the course is manageable. But certainly it will take, it's just as the old course, this one will take it. People have to keep working throughout the year. So yes, it is doable, but as I say, it depends on students having met ideas in Year 11 and mastered them and to move on. E.g., circular functions, they have to know all about it really before they get to Year 12. So that would be a bottom line. That occurs in so many different places, in vectors and complex numbers and in the calculus. The calculus, by the way, for people that feel as if the course has been watered down, that sort of area, has actually got more in it now, because it's got surface area of surfaces of revolution, for instance, and integration by parts is developed, which because of the theme of the course, you can have reduction formula. So a lot of that type of mathematics, which is in the calculus sort of area, is actually slightly strengthened from what it was in the past. And it certainly would counteract any feelings people have about the loss of some areas. Thank you.
Okay. So we've got only about 5 minutes left. So I'm just going to roll through and look for some specific questions that are best kept for the authors, so that we can try to get to everyone as much as we can. Anything that's remaining at the end, I'll let you know now that we will certainly respond to it following the webinar over the next few days. But in the meantime, let me go to Thai Nguyen. How are the investigations structured within the textbook? It was mentioned that these can be completed across lessons while teaching and not as a separate thing. Is that correct?
Yeah, we'll throw that to Michael, and then other authors can comment as it relates to their specialist subjects.
Great.
I can certainly say that was the intent, that you don't have to say to the students, go away and do an investigation for 2 weeks. That's not the idea. It can be built into your teaching all the way through, and it can be part of a topic you're teaching. It's the conditions of it aren't particularly arduous if you look at them in the study design. We've actually given suggestions for investigations inside the textbook, but we'll also have online investigations, of course. Once something is in the textbook and we give solutions in the solutions to the investigations, okay, they're useful, but they're useful as examples. You might take them and develop them further or take a different turn, but there'll also be online investigations that you can work with. But it's certainly a major part of our Year 11 courses, and we've addressed it throughout the book in all areas. And in specialists and in methods, there's a possibility that you could bring in pseudocode and coding into your investigations, and it would be a useful place to do it, where the students have a little bit of chance to explore. But others may like to talk about that too. There's one other question I've seen, which is about the nature of pseudocode. There won't be a mandated pseudocode form, but the structures of all coding are about the same. So you've got iteration, you've got if statements, and basically once you've got those, you've got the tenets of all coding. So there's nothing actually will be prescribed, but there are ways that we can expect it to be presented. In exams, it has to be mainly given through sections of pseudocode that can be interpreted in a non-highly technical way. That'd be the way to describe it.
Just to add to that, I mean, we've tried to settle on the format that we think is most clear to students. So it's not one particular format. It's to some extent, it's kind of a bit of a hybrid, but we've aimed for clarity as much as possible, knowing that this may be new to students and teachers alike. So yeah, clarity is really what we've aimed for.
Great. I've got another question here from Katie. Are there more open-ended questions or complicated application questions provided in these new editions?
Go to Michael first of all, and then David, Treby and others can comment as well.
I would have thought we had lots of complicated questions already from feedback. Some people tell us too many, but on the other hand, it's yeah, we've got more in there now, and some of them, they're not open-ended inside the actual questions in extended response or anything like that, because that's not what's expected in exams. But we have got investigations now and problem solving. So yes, there are such things in the book, but we've just got certainly questions that will stretch any student, I think, in those textbooks. And there's more than there was in the past.
Great. So moving on to Emma's question with Boolean, or I apologise, I'm not great with the pronunciations, the algebras in 1 and 2 specialist maths. Currently, the notation in particular uses symbols and V. In other texts, they use plus and full stop. Are you aware of what the VCEE is preferring as their notation?
Okay, the answer is it's not prescribed. We've actually used that form simply because it locks into the other ideas of sets, intersection, and union. It locks into the ideas of probability statements, and it fits into the structures of formal logic. Whereas if you actually treat Boolean algebras with pluses and multiplications, it actually obscures some of those facts. So we made a deliberate choice to go along this path. The other one is not wrong, but it actually doesn't transfer as easily. But the VCA has not stipulated. By the way, the one thing you can notice about the 3-4 study design is it's been quite deliberate that proofs about Boolean algebras will not be asked in year 12. Check it out. It's been a deliberate decision that is not in it. So the notation in itself will not be a problem because it's not examinable. So I don't think you'll see an explicit explanation of what has to be taught in that way, because it will be at 1-2. That will be contained in 1-2. Some of the thinking behind it could be examined in year 12, but generally they couldn't just start asking Boolean algebra questions in year 12 exams, simply because it's the one thing that's been left out of that list about what can be proved.
Of course.
I mean, certainly that chapter should be viewed as kind of like a natural pairing with the proof chapter. And so, you know, as Michael said, you don't really need to be too worried about how that might be presented in year 12, because it won't be. But all the same, the ideas in that chapter certainly support and augment all of the content of the proof. So that's where we see that chapter as being particularly important.
Kim, would you, I think there's one from John Taylor. Maybe that would be a good one to end on if we're running out of time.
Yeah, let's go with this one. Okay, John, we are in the process of adjusting our Specialist Maths 1-2 course at the moment, and we're finding it extremely difficult to fit in the curriculum. We're trying to work out what we can subtract in order to add new content. At first, we thought we could take out statistics. Statics.
Yep.
But we see buried as an application of vectors as statics and possibly dynamics. Does this mean that we can't, in fact, delete this from our course? How is this treated in the new books? Great question.
We'll go to either Michael or David Treby on that one.
Look, I'll start, and I'm sure David can join in. I think those decisions are difficult. The extensions, the statics are put in there as an example, an application of vectors. So it doesn't mean you actually spend a week on it for teaching. It just means maybe you glance at it more or less in the context of saying this is a use of vectors. So I think you actually have to pick and choose. There's things later on in the course which are probably less likely to flow on, such as transformations. It's nice to do those things because they're very helpful, but there are parts of that course where you can make sensible choices, I think, that you may not emphasize as much. It's a prescribed course, so you have to teach them, so I'm not saying that. But what you can do is balance the emphasis you put on different things. I think that'd be the way to look at it. David?
Yeah, I mean, I could just add to that, obviously, that, you know, to some extent, you know, how the exams look is a little up in the air at the moment. And so we've just tried to be as thorough as we possibly can in writing the book to cover kind of all bases. And so as it becomes more apparent how it is that this material is going to be assessed, you know, teachers will obviously be sort of naturally adjusting the emphasis placed on the different parts of what we present in those books. And, you know, teachers obviously, you know, emphasize or de-emphasize according to, you know, how things play out in the exam space.
Just to add to that, just to connect it to the exam generator feature that is added to the online teaching suite, it is one of the things about any textbooks that they come out in the year before the first exams are run, and then the nature of exam questions changes over time, and it sort of dates in some ways, some aspects that were our best guesses or our best advice at the time. But the good thing about the exam generator is it will allow us to keep adding the past year's exams year upon year, as well as new authored questions into the bank, so that teachers will have material to use alongside the textbooks to make sure that material is set in the way that matches or models the trend in the way that questions are asked.
Great. Well, thank you, everyone. Really, I think we need to end the Q&A session. That went over time a little bit, but I'd like to keep everyone sort of inside the time frame. So if you don't mind, can we just pop up the final few slides? If we haven't got to your question yet, please know that we'll be going through all of the questions and responding to them personally. Over the next week or so, you should receive something via email from either one of the consultants, or we're happy to reach out to the authors and get specific responses to any questions that you might have along the way. Know that within the next week or so, you will receive an email that will have not only a link for your feedback of this evening's webinar, but also the opportunity for you to order whichever free book that you would like to receive. So let's begin with the slides firstly, and if you could move on to the next slide, please. Thank you. So really, I just wanted to briefly brush over price points for everyone. The print and digital at $89.95 and digital only $69.95. Teaching Suite is $149.95. Next slide, please. So availability, probably the most important thing that everyone wants to know about. Firstly, page proofs. Know that units 1 and 2 for methods are available now, so you can go online and receive those. And also 3 and 4 will be ready in July. So publication dates are looking good. Units 1 and 2, 1st of August, and 3 and 4 for November. So that's great news. Next slide, please. Thank you. So the page proofs for specialists, again, units 1 and 2 are ready. So have a look online. They're available via our website. Follow the link on there. But I'm sure that we'll also be able to add a link to that inside the email that we send out to you too, if you wanted to wait for that. The units 3 and 4 page proofs, August, and publishing dates, again, looking good. 1st of August for units 1 and 2, and 3 and 4 in December. Next slide, please. So I just wanted to put the faces of our consultants back up on the screen for everyone. Know that if you've got specific questions about the textbooks, pricing, publication dates, I know we just spoke about them, but sometimes it just falls out of your mind. Of course, if you want to have any PD as well, please reach out to your consultants. Everyone's online here, but know that this specific page that we've got printed on the screen is also on our website. So please just go on there and communicate with the person that you would like to speak with, and they will certainly get in touch with you with any information that's needed. On to the final slide, thank you. So again, I just wanted to touch on the email that will be coming out to you, and it will be within the next week or so. Expect to have a link in there for your feedback. Please give your feedback. It's something we really learn from, so put any information that you can in there that you feel is relevant to this evening's webinar, and know that we will also get back to all questions specifically and make sure that we've got appropriate responses from authors as well. Thank you so much for your participation this evening, and thank you to all of our authors. Have a good evening, everyone. Thank you.